Alright, so this is part 2 of the review video for the final exam. We're going to be doing numbers 31 through 45 in this video, and then your homework for today will be to do 46 through 60. So we'll just go ahead and get started. On number 31, it says a food store makes a 10-pound mixture of granola clusters and raisins. The cost of granola is $2 per pound, clusters cost $3 per pound, and raisins cost $1 per pound. The mixture calls for twice as much granola as clusters, and the total cost of the mixture is $18. How much of each ingredient did the store use? So we have 3 different variables. So I'm going to say granola is X. I think it's pounds of granola, and then pounds of clusters will be Y, and pounds of raisins will be Z. So we've got 3 variables, so we're probably going to have 3 equations. So we know that it's a 10-pound mixture, so the pounds of all of these added together would have to be 10. And then the cost of granola is $2 per pound, cost of clusters $3 per pound, and the cost of raisins is $1 per pound. And we know that the total cost for the mixture was $18. So 2 times X plus 3 times Y plus 1 times Z, which we can just write as Z, will equal 18. And then the last one is the mixture calls for twice as much granola as clusters. So the number of pounds of granola will be twice the number of pounds of clusters. Where's clusters? Clusters is Y. So the granola will be twice the amount of clusters. So we need to solve to find out how much of each ingredient the store used. So if you have the calculator software, then you can solve that using the software, and it will tell you what each of your variables equals. Or you can do it by hand. It's completely up to you at this point. I'm going to work it by hand. So X equals 2Y. So I'm going to go back into the first equation. Instead of writing X, I'm going to write 2Y plus Y plus Z equals 10. 3Y plus Z equals 10. And I'm going to write this in terms of Z. Sorry, I'm going to solve it for Z. So I'm going to move the 3Y and write it in terms of Y. So Z equals negative 3Y plus 10. I have X in terms of Y as well. So I'm going to plug both of those into the second equation. So 2 times 2Y, 2 times my X, plus 3Y, plus Z, which is negative 3Y plus 10, equals 18. 2 times 2Y is 4Y, plus 3Y, minus 3Y, plus 10, equals 18. And these two cancel, so I get 4Y plus 10 equals 18. Move the 10 over. 4Y equals 8. Divide by 4. And Y equals 2. And I know that I wrote the other 2 in terms of Y, so I can go back and plug that value in. So Z equals negative 3 times 2 plus 10. So Z equals negative 6 plus 10. Z equals 4. And I'll do the same thing with the X. X equals 2Y. So X equals 2 times 2, which means that X equals 4. So then for my solution, it asks for how many of each. So there were 4 pounds of granola, and Y, 2 pounds, of clusters and 4 pounds of raisins. Number 34. Identify. Why did I jump to 33? This is 31. Sorry. That was number 31 that whole time. 32, that makes more sense. 32, identify the vertex and the axis of symmetry of the graph of the function y equals 2 times x plus 3 all squared minus 2. So we're looking for the vertex and the axis of symmetry. Vertex, when we're in vertex form, we get from this and this. So my vertex is the opposite of the inside, -3. The end as it is, -2. Axis of symmetry is the x value, so x equals -3 is the line that would cut that quadratic in half. 33, identify the maximum or minimum value and the domain and range of the graph of the function. Y equals 3 times x plus 3 squared minus 4. So again, we're in vertex form. So I'm going to take the vertex from here, but we're not looking for the vertex this time. We're looking for the minimum or maximum value. A is 3, which is positive, so this opens up, which means I have a minimum. So the minimum value is the y value of the vertex, so my minimum value is -4. And then it says the domain and the range. Domain will never change, -infinity to +infinity. And the range we get from the vertex, so my minimum value goes down to -4, but it's going to go up forever, so my minimum is -4, and it goes up toward +infinity. (34) What steps transform the graph of y equals x squared to y equals 2, x plus 2 all squared? Let me write it down. Minus 3. So we have one here, the second one here, and the third one here. So my transformations, the one with the 2 in the front, so my first transformation is a vertical stretch by a factor of 2. There's no negative, so I don't have any reflections. The plus 2 on the inside is a horizontal shift to the left. We go opposite 2 units. And the last one, we take it as it is. It's a vertical shift down 3 units. So those are my 3 transformations on that function. Then on number 35, what are the vertex and the axis of symmetry for the equation? Let me write it. -2x squared plus 4x minus 12. We're looking for the vertex and the axis of symmetry. So the vertex, when we are not in vertex form, we take from our AB values. So we got -2, 4, -12. X value of the vertex is -b over 2a, which is also going to be our axis of symmetry. So -b would be -4, over 2a, 2 times negative 2, which is negative 4 over negative 4, which is positive 1. So x equals positive 1 is my axis of symmetry and the x value of my vertex. And then I plug in a 1 to get the y value. So negative 2 times 1 squared plus 4 times 1 minus 12. Negative 2 times 1 plus 4 minus 12. Negative 2 plus 4 minus 12. Negative 14 plus 4, which is negative 10. So the y value is negative 10, so 1, negative 10 is my vertex. Looks like that's all we were looking for, the vertex and the axis of symmetry there. Oops. And then number 36. What is the maximum or minimum value of this function and what is the range? So we have a similar function. We need to find the maximum or minimum value, which we can find from the y value of the vertex. So we need to find the vertex first. We're going to find negative b over 2a. A is negative 2. B is 8. C is negative 2. So we have negative 8 over 2 times negative 2, which is negative 8 over negative 4, positive 2. So the x value is positive 2, but when I'm looking at minimum or maximum, I just want the y value. So in order to find the y value, we'll plug that value in. Sorry about that. So we're going to plug the x value in to find the y value, which will give us the minimum or the maximum. So we have negative 2 times positive 2 squared plus 8 times positive 2 minus 2. Negative 2 times 4 plus 16 minus 2. Negative 8 plus 16 minus 2. 8 minus 2, 6. So our minimum or maximum value is a 6, but our a value here is negative. So this is a quadratic or parabola that is facing down, which means we have a maximum value. And that maximum value is 6. And then what is the range? The range depends on that maximum or minimum value. So since it is a max, it's going to be on the end here, and then toward negative infinity. $37. Let me zoom in a little bit. All right. 37. What is the vertex form of the equation? So now we're converting, which means we're going to be completing the square. So x squared minus 4x plus something equals negative 9 plus that same thing. So I move the 9 to the other side, and then we're going to complete the square on the left. X minus 2 squared, so 2 squared is 4, goes in both blanks, equals negative 9 plus 4 is negative 5. Add that 5 back over. So y equals x minus 2 squared plus 5. And then number 38, what is the expression in factored form? Oops. So 38, we've got x squared plus 17x plus 72. So I want to factor this, which means I want to find two numbers that will multiply to 72, but add to 17. So those two numbers are 9 and 8. So that's the expression in factored form. (39), we're doing the same thing. We're trying to factor. So we're factoring x squared minus 18x plus 80. So we want two numbers that will multiply to a positive 80 but add to a negative 18, which those two numbers are negative 10 and negative 8. The negatives together will give me positive 80 on the end, and then the negatives together will give me negative 18 in the middle. Now on 40 through 44, we've got different numbers in the front. So on number 40, I'm going to use slide and divide. So 5x squared plus 32x plus 35. I'm going to take that first number, slide it on over to the end. I've got x squared plus 32x plus 35 times 5, which is 175. Now I need two numbers that multiply to 175 but add to 32. And it's 7 and 25. So x plus 7, x plus 25. But we still need to divide by what we multiplied originally. So 7 over 5 is a fraction, so it's going to come out to the front. So we've got 5x plus 7. And then 25 divided by 5 is 5, so x plus 5. Number 41, we're going to do the same thing. 4x squared minus 25x minus 21. Multiply the last number by 4. X squared minus 25x minus 84. And then we want two numbers that multiply to negative 84 but add to negative 25. Those two numbers are 3 and negative 28. So x plus 3, x minus 28. And then we'll divide by 4. This creates a fraction, 3/4, so the 4 comes out to the front. 4x plus 3. 28 divided by 4 is 7, so x minus 7. On 42, we'll do the same thing. Nine x squared minus 12x plus 4. We're going to take that first number, multiply by the last. X squared minus 12x plus 36. Two numbers that multiply to 36, positive 36, but add to negative 12. We have x minus 6 and x minus 6. We've got to divide by 9 on both. Creates a fraction, but it can be simplified. So 6 over 9 is 2/3. So we're going to put the 3 in the front. Let me rewrite it so we can see. X minus 2/3 instead, and x minus 2/3. So we'll take the 3 to the front. 3x minus 2 and 3x minus 2. Which if we have the same thing twice, we can just write it as 3x minus 2 squared, since it's multiplying by itself. 43, x squared minus 25. I have two terms, which is my giveaway that this is most likely a special case. And I see that I'm subtracting a perfect square. So what is a special case? We've got the difference of two squares. So one will have a plus, one will have a minus. And the square root of that last number will go in both of those blanks. So x plus 5 times x minus 5. 44. What is 49x squared minus 25 factored? So again, we have two terms with a square, and we got to check, are they perfect squares, which 49 and 25 both are. So we'll take the square root of both and put them in the blanks, one with a plus, one with a minus. We already know 25 is 5. Square root of 49x squared will be the square root of 49, which is 7, and x. If you struggled with 43 and 44, this would be factoring special cases, if you need to go back and watch those videos. And last one for this video, 45. What are the solutions to the quadratic equation if x squared plus 6x equals negative 8? So whenever we have a quadratic equation, we always want it to equal 0 first. So I'm going to move this 8 over. X squared plus 6x plus 8 equals 0. And we'll see if we can factor first, because that's going to be our easiest bet. And I would need two numbers that multiply to 8 but add to 6. And I know 4 times 2 is 8, and 4 plus 2 is 6. So it's x plus 4 and x plus 2. It says to find the solutions, so we'll set each of those equal to 0. And then solve. So we'll subtract 4, and x equals negative 4. Subtract 2, and x equals negative 2. So x equals negative 4 and negative 2. Oops. So then that is it for the video portion. Remember that you do have all the answers on the file that you download it with, so that way you can go back and check on the ones that are not featured in the video. Also, we're going to have open Zooms all week, so that way you can pop in and ask your questions, especially tomorrow, since nobody in Algebra 2 will be testing. So if you are confused on anything that we just did, or if you tried to do the remaining ones and you are confused still, then go ahead and jump into those Zooms so that way you can get your help before the exam.